Hello friends, in system of linear equation we have studied what is the linear equation, then system of m linear equations in n unknowns, then its matrix form, argumental matrix form, then homogeneous system, non-homogeneous system, and then consistent and inconsistent system. Then how to solve that system with help of Gauss-Jordan elimination method, Gauss elimination method, with help of row echelon form of matrix and row reduced echelon form of matrix. So in this lecture we will solve some examples on from exercises. So we will take the example. Consider system of equations. Consider system of equations x plus y plus 2z, x plus y plus 2z is equal to a. Second equation is x plus z equal to b, and third equation is 2x plus y plus 3z is equal to c. So that system is consistent if if and only if c is equal to a plus b. C is equal to a plus b. So this is our example. So here matrix form of system is matrix form, or we will take the argumental matrix form. Argumented matrix form of system is AB is equal to, we would write it in form AB form is equal to coefficients of x 1, 1, then 2 coefficients of x, then coefficients of y. Okay, so this is 1, then in second equation y term is absent, so its coefficient is 0, then 1. The next one 2, 1 and 3, and here it is A, B, C. In some books in argumentative form this vertical line is not given. In our book Elementary Linear Algebra by Howard Anton, this vertical line is not put there. So this is the matrix, argumentative matrix form of system. We have to reduce this form to either row echelon form or row reduced echelon form by applying the sequence of suitable row operations. So there are three types of row operations. One is interchanging of row operation Rij. Second is multiplying some row by non-zero scalar k, Ri, and then adding k multiple of ith row in jth row, say Rj, so Rj plus krj type. So such type of three row operations are there. So now here in first column or in first row, first entry is 1. So that is the leading one in first column. We will use that 1 to make below entries to be zeros. So for that we will apply the operations R2 minus R1, and second one is R3 minus 2R1. Just by using this leading 1, we have to make below entries to be zeros. Below entries zeros. Using this leading 1, you have to make below entry 0, then this form will become equivalent to first row as it is 1 1 2 A, so there is no change. 1 minus 1 gives us 0. 0 minus 1, it is minus 1. Then 1 minus 2 is a minus 1 and B minus A. Then 2 minus 2, 0. 1 minus 2, minus 2. Oh, 1 minus 2 is a minus 1. And 3 minus 4, that is minus 1. The next one is C minus 2A. Then you have to convert this entry in second row to the entry to be 1 if it is non-zero. If it is non-zero. If it becomes 0, then you have to identify the below row in which corresponding entry is non-zero, and you have to interchange row in such a way that that entry becomes non-zero in 2 position, and if all entries are zeros, then you have to look towards the next entry there. So you will not get leading 1 in that position. So here you have to convert this entry to be minus 1. So we will apply the operation minus R2. So this gives us row equivalent form. This gives us equivalent form 1 1 2 A 0 1 1 A minus B. Third row as it is 0 1 or minus R3 also I can take. Okay, or keep it as it is a matter, and C minus 2A. Then now this is your leading 1. You have to use this 1 to make below entry to be 0. So applying the operation R3 plus R2, this gives us equivalent form 1 1 2 A, then 0 1 1 A minus B 0 0 0, and then adding R2 here, C minus 2A plus A gives us C minus A minus B addition. So this is your row echelon form. What is this? Row echelon form. Okay. So from row echelon form, row echelon form, row echelon form R rank A is equal to 2 is equal to rank of AB if and only if your C minus A minus C minus A minus B is equal to 0, that is C is equal to A plus B. And we know that the system is consistent if and only if rank A equal to rank of AB. Okay. And therefore system is consistent if and only if C is equal to A plus B. Is it clear? So this is the way of solving example. Now we will take the next example. I think light required. Yes sir, light required for it. We will take now next example. Find the solution set of each of following linear equations. Find the solution set of each of following linear equation. In that, first is 7x minus 5y is equal to 3. So there is only one linear equation in two variables. So one variable must be depend on other. So we'll put y is equal to t. Then what is your x? X is 3 minus 3 plus 5t by 7. And therefore solution set is S is equal to set of ordered pairs. X is 3 plus 5t by 7 comma t where t belongs to R. T belongs to R. Then second equation 3x1 minus 5x2 minus 5x2 plus 4x3 is equal to 7. Again there is only one linear equation in three unknowns variables x1, x2, x3. So x1 is a leading variable for this equation, x2 and x3 are free variables. We have to assign some parametric values for free variables x2 and x3. Put x2 is equal to S, x3 is equal to t. Then what is your x1? x1 will become 7 plus 5s minus 4t upon 3. Okay, so 3x1 is 7 plus 5x2 minus 4x3. x1 is taking 3 on that side and assigning values for x2 and x3 will get this x1, and therefore your solution set. What is the solution set? x1 is 7 plus 5s minus 4t by 3, x2 is s and x3 is t, where s and t are real numbers. This is your solution set. So in this way you can obtain the solution sets. You can write that solution set in row matrix form x comma y, x1 comma x2 comma x3, or in column form also x1, x2, x3. So any way is allowed. The next one is say D is in exercise there, 3v minus 8w plus 2x minus y plus 4z is equal to 0. This is the homogeneous equation in which right hand side is 0, therefore it is homogeneous equation. These are non-homogeneous equations. So now this equation is in 1, 2, 3, 4, 5 variables. One equation in 5 variables. So, and therefore 4 variables are, one variable is leading variable, phi is a leading variable, and w, x, y, z are free variables. Put say w is equal to a, x is equal to b, y is equal to c, and z is equal to d. Then your phi will become, taking that on that side, 8w minus 2x plus y minus 4z, which is equal to upon 3, which is equal to 1 by 3 in bracket, 1 by 3 in bracket, 8w means 8a minus 2b plus c minus 4d. And therefore your solution set S is equal to, I'll write in say column form phi w x y and z. What is your phi? 8w minus 2x plus y, 8a minus 2b plus c minus 4d by 3. Then what is w? A, then b and c, d, where a, b, c, d are real numbers. A, comma b, comma c, comma d belongs to R. So in this way, you can write that solution set column wise also. Column wise also. Now we'll take the examples from 1.2 exercise. In the below exercise, exercise 1.2, question 2. In below exercise, suppose argument a matrix, okay, in following argumental matrix for a linear system in following argumental matrix for a linear system has been reduced to row echelon forms. Solve the system. So in that, first example is 1 minus 3 4 7 0 1 2 2, then 0 0 1 5. So this argumental form is given to us. Now, for this argumental matrix form, for argumental matrix of system of linear equation, this is the row echelon form. So it is the system of, so this is your constants. So this is column of first variable. I will denote that variable by x. Okay. Then this by y variable and this by z. And this equal to constants. So from row echelon form, reduced system is, what is your reduced system? Is x minus 3y plus 4z is equal to 7. In our lantern, this vertical line is not given. So you have to assume that last column is column of unknowns if it is the augmented matrix form. If it is augmented matrix form. Then second one is 0x plus y plus 2z is equal to 2. And next one is z is equal to 5. So by back substitution, z is 5, then y is equal to 2 minus 2z is equal to 2 minus 2 into 5. That will become minus 8. Okay, x is equal to 7 plus 3y minus 4z, which is equal to 7 plus 3 into, this is a minus 8, and minus 4 into z is 5. So it will become 7 minus 24 minus 20, and it will become minus 37, and therefore solution is, always we are writing solution first variable value, then second, and then third. X is a minus 37, y is equal to minus 8, and z is equal to 5. Z equal to 5. Is it clear? So this is the way of writing solution from row echelon form of given system. Row echelon form of given system. Here, if you assign unknowns or variables x1, x2, x3, then we will take here reduced system in x1, x2, x3. Or if you take that system in variables pqr, then I will take the values for pqr to be these values. So it depends on you. Choices of variable doesn't matter. Okay. But in given problem, if variable notations are given, then we have to use only that notations. But here I can take any notations for that variables. Then the second equation says, one more example on it. So I will take here says C. From exercise I will take directly. Okay, C is 1, then 7, minus 2, 0, minus 8, minus 3, 0, 0, 1, then 6, then 5, 1, 6, 5. Then 0, 0, 0, 1, 3, 9, and last one is all entries are zeros. So here we have more variables, so I will denote variables by, say this is my x1 variable, this is my x2, this is my x3, this is my x4, x5, and these are constants. Now this is your leading one, this is your leading one, and this is your leading one. Okay. So in row echelon form, column C1, then C3, C4 contain leading ones. Therefore C1, C2, C3 are leading or pivot columns. columns. And variables corresponding to that columns x1, x3, x4 are leading variables. Therefore, x1, x3, x4 are leading variables, and remaining variables x2 and x5, are free variables, Reduced system is, what is the reduced system is x1 plus 7x2 minus 2x3 minus 8x5 is equal to 3 minus 3, then x3 plus x4 plus 6x5 is equal to 5, and then x4 plus 3x5 is equal to 9. Now x2 and x5 are free variables, so assign some parametric values to those free variables. Put x2 is equal to, say yes, x5 is equal to t. Then is it clear? So then from last equation x4 is equal to 9 minus 3x5 is equal to 9 minus 3t. x3 is equal to 5 minus x4 minus 6x5. So 5, what is your x4 minus in bracket 9 minus 3t, right, and minus 6t. After simplifying we will get 5 minus 9 is minus 4, minus plus 3t, minus, so minus 3t, minus 4 minus 3t. Then what is your x1? x2 is earlier taken. Okay, this is your 9 minus this one, x3 is equal to this, x1 is equal to, from first equation x1 is minus 3 minus 7x2 plus 2x3 plus 8x5. Now here I will substitute values minus 3 minus 7 times s minus 7s plus 2 times x3 minus 4 minus 3t plus 8 times x5, what is x5t, plus 8t. After simplifying we will get minus 3, and this is 2 minus 4, 2 into minus 4 is minus 8, minus 8 minus 3, so that is minus 11. Then minus 7s, and how many t's? This is minus 60 plus 8t, so it will become 2t. So this is my x1, and therefore solution set is minus 11 minus 7s plus 2t, x2 is minus, x2 is s, x3 is minus 4 minus 3t, then x4 is 9, write continuously, 9 minus 3t, and what is your x5? x5 is equal to t, such that st belongs to R. st belongs to R. This is your solution set. We'll take one more example. Is it clear? Then G, I am denoting it by G dash because I am making some changes there. So what is the matrix? 1. Here instead of 0 in your book, minus 6 is given. So I am replacing that minus 6 by 0 for explaining some additional information. 3 minus 2. Second row 0 0 1, 0 4 7. Then 0 0 0 1, then 5 8, and last is all zeros. So again, this is my column of x1, second variable x2, this is x3, this is for x4, this is for x5 variable say, and this is for constants. Okay. Now this is my leading one, this is leading one, and this is leading one. So here column C1, C3, C4 contain leading ones, So corresponding variables x1, x3, x4 must be leading variables. Then remaining variables are free variables. x2, x5 are free variables. Now, if you don't identify x2 to be a free variable, if I write firstly reduced system here, reduced system, then I get the system x1 plus x5. Okay, 3x5 is minus 2, x3 plus 4x5 is 7, x4 plus 5x5 is 8, and x2 variable doesn't occur there. x2 variable doesn't occur there. So students are assigning x5 to be parametric value, x5 to be parametric value, but they doesn't assign any parametric value to x2. And then they are getting the values, solutions for x1, x3, x4 in terms of that parameter x5 is equal to say t. And then lastly they are writing x1 is 0 directly. x1 is 0. And that is the mistake. That is mistake. So firstly, from row echelon form you have to always identify which column contain leading ones, variables corresponding to that column, always variables corresponding to that columns are leading variables, and then remaining variables of system are free variables. Okay. So here, and that's why I have replaced that minus 6 by 0 here. Minus 6 by 0. Only that is the reasoning. No reason is there. So here columns C1, C3, C4 contain leading ones. and therefore x1, x3, x4 are leading variables and remaining variables x2, x5 are free variables. Leading elements are also known as pivot variables. Okay, leading elements are also known as pivot ones doesn't matter, and that columns are known as pivot columns. So reduced system is, so what is the reduced system? Reduced system from row echelon form, reduced system is your x1 plus 3x5 is equal to minus 2. Second equation is x3 plus 4x5 is 7, and then x4 plus 5x5 is equal to 8. Put, say, x2 is equal to s, x5 is equal to t, then x4 is equal to 8 minus 5t, x3 is equal to 7 minus 4t, and x1 is equal to minus 2 minus 3t. Solution set is, say, s is equal to x1 is minus 2 minus 3t, x2 is s, then x3 is 7 minus 4t, x4 is 8 minus 5t, then t such that s comma t belongs to R. So this is my solution set of the system. So row echelon form, row reduced echelon form plays very important role in solving the system of equations. From row echelon form, number of non-zero rows for row echelon form of A gives us rank of matrix. Number of non-zero rows for complete argumental matrix AB gives us rank of AB. If that rank A equal to rank AB, then system is consistent. And if that rank A equal to rank AB is number of unknowns, then system is consistent and it has unique solution. If rank A equal to rank AB less than number of unknowns, then system is consistent and it has infinitely many solutions. If rank A is less than rank of AB, rank A is strictly less than rank of AB, then system is inconsistent and it has no solution. It has no solution. So with the discussion, we'll stop our today's lecture here. Thanks for listening lecture carefully. Bye bye.